whilst this is a calculator paper, if you just put in root 396 into your calculator and it gives this 6 root 11, you can't use that as a reasoning. Show that means you have to basically do it without a calculator. You must show your reasoning and what's happening. So maybe the best thing to do actually is do it the other way around. If I've got 6 root 11, then there's a rule of surds, which means like if I had 2 root 7, for example, there's a rule that says you can bring the 2 inside the root if you square it. The long way of explaining it, I suppose, is that I can write 6 as root 36, which is 6 squared, root of 6 squared, and I can times that by root 11, and then that makes a bit more sense maybe, that why I can bring it in but I have to square it. So then I'm going to get 36 times 11, and I feel like it should be sufficient to, 36 times 10 is 360, add on 36 is 396, and I feel like that is sufficient for being able to solve this problem. I think because it says show that root 396 can be written as 6 root 11, I might just do it the other way around. So root 396 equals 36 times 11 equals 6 root 11. I'm just going to put this extra step in just to be absolutely sure. Now, if they said simplify root 396, you'd have to spot that. You'd have to spot that 36 is the biggest square number that goes into it, but it does go into it, and you have to divide and so forth if you didn't have a calculator. But we can get away with it here by sort of doing it the other way around. But in any case, you might maybe you did it the way I've just said. Maybe you did do it this bottom way, but that's sufficient to be able to show that. Okay, second bit. Without using a calculator, show that this horrible fraction can be simplified to 6 plus 4 root 2. Okay, this is a rationalizing the denominator question. It doesn't actually, sorry, I didn't quite write properly. It doesn't say that at any point, but that's what it wants us to do. Because here we've got a denominator, and here in the answer we do not. Secondly, we have a denominator that is not rational. That means it's got a surd in it essentially, and it can't be like simplified nicely. So we need to somehow get rid of it. Now what you have to do is you have to times by 2 plus root 2, because that will mean that they cancel out. If you try and times by the same thing, it won't. When you have 7 over root 7, you can just times top and bottom by root 7. That's not going to work here. You have to sort of switch the sign around. Let's just see why. Okay, so I'm gonna write it out again. I'm now basically multiplying my fraction. Okay, not left myself much space. Gonna have to come down here. That's all right. So let's multiply the first one. It's going to be 4 times 2, 8. 4 times root 2, so plus 4 root 2. Then plus 4 root 2 again. And then finally plus 2 root 2 times root 2. It's going to do a little thing up here to show that. 2 root 2 times root 2. Well, root 2 times root 2 is just 2, and then 2 times 2 is 4, so this just becomes plus 4. Divided by 2 times 2, which is 4, 2 times root 2, which is 2 root 2, but now I get minus 2 root 2 in there, so that is the whole point of changing the sign, because these two are going to cancel, and I'm left with minus root 2 times root 2, which is minus 2. We're nearly there. Now I just need to simplify it, get 6 plus 4 root 2. Okay, still going to do this without a calculator. 8 plus 4 is 12, so I'm combining my like terms. 4 root 2 plus 4 root 2 is 8 root 2. And then I'm going to be dividing by 2, because 4 minus 2 is 2. Nearly there. I can now essentially divide the 12 by 2 to to give me 6, and the 8 root 2 by 2 to give me 4 root 2. Quite a lot going on here, and this is the last question in the paper. Like I hope I haven't made too many assumptions as I've gone along, where basically you need to know this little trick to rationalize the denominator. You need to be able to multiply out double brackets, 2 lots involving surds, see that this bottom one cancels, we're left with this, and realize that we can in fact just it comes back to the fact that if you have, say, 3/7 plus 2/7, then we get 5/7, or even 2 plus 3/7. What I'm trying to say is that I can split this thing back into this thing, which is what I sort of did in this last step here. Anyway, we know we've got the answer, so we can be really happy with that. It's very unlikely we would have made like a bunch of mistakes that would sort of cancel out to give the correct answer. Possible, but unlikely. 6 marks. There we go.